So there we go. We're recording. And then what I'm going to do is I've got a screen to share. And I'm going to share my screen. And then we're going to, it's kind of like a blank paper that I've got set up, and we're just going to work some problems together. Okay, so share screen. Okay, so you should see my screen now. It looks like notebook paper. And that's what I'm going to use. So the first thing I want to review is the stuff that we did on Monday. So the brand new exponential logarithmic equation type things, because it's new, it's probably what we need the most extra work on. But you'll notice that as I do these problems, remember, even though they're the new rules, we still use the old rules too. There is rarely a function where we don't use the power rule, and most of our functions we use the chain rule. Nathan, you are going to have to shut that down. Whew. Okay, anyway. Are you done? Okay, we'll be done then, okay? All right, sorry. I don't know if it's just because I have a headache or what, but it's like every little sound in my house right now is just makes me want to punch people. So anyway, let's start with reviewing the basic rules that we learned on Monday. So we learned that the exponential function that we're going to use a lot, y equals e to the x, we learned that when we take the derivative of that, even though I had mentioned that the process of getting from function to derivative is a complicated one, after all the complicated work gets done, what the result is exactly the same thing we started with. Which you can imagine if we did all this in class, it would have been kind of frustrating, right? But we didn't have to, you guys. So we have e to the x, we take the derivative, it's exactly the same thing. And that was the easy part. And then we started making it a little more difficult. So this is just basic e to the x, where x is the only thing in the power. But then we looked at some problems where we had more than just x in the power. So we started out pretty simple, just adding a coefficient on that x. So we have e to the 2x. You guys, because there's an e in this function, I know the very first thing I'm going to do is I'm going to use my exponential rule for taking derivatives. So I see the e to the power. Yes, it's to the 2x, but because it's an exponential term, sorry, because it's an exponential term, my first technique that I use is the exponential one. I bring the e term down exactly as is. So even though it's not just an x in there, I bring down whatever it is exactly as is. But because it is not just an x, I have to now use the chain rule. So remember the chain rule, no matter what function you are differentiating, the chain rule says that whatever this is, in this case it's up in the power, whatever x term you have that's not just x, you have to take the derivative of that too, and you always multiply it onto the end. So in our case, the term is up in the power. It's not an x, it's a 2x, so I took the derivative of that and I put it on the end. Now, that is totally a correct answer. It has all the components it needs. But usually we would put that 2 in the front. It looks a lot nicer. I did did some trial and error in MATLAB though, and it takes it like that too. But just for simplicity and just like ease of reading your problems, you might write it this way because it's more clear. Usually we put numbers in front of exponential terms. But yeah, so it's just exponential rule with some chain rule. Let's do another one. And you guys, on this one, so I put some problems in your homework that have a coefficient on your E term, and I forgot to do one like that in class. I'm pretty sure I didn't do an example that had a coefficient in it. I'm sure, honestly, if you've worked on your homework, you probably noticed, oh, it's a coefficient. I know what that does, but just in case you didn't, or you thought it might do something different, we'll do one of these. So you guys, the 5, it's a coefficient on my exponential term. We know what happens to coefficients. It doesn't matter what your function is. If you've got some number multiplied in the front, it is going to come down because it's a coefficient. It just comes down along with us, just like it did before. And then, so I bring the coefficient down, then I deal with the exponential part of the problem. E to the 3x is an exponential term, which means I have to bring it down exactly as is into my derivative. But because it is a 3x instead of just x, I'm going to go ahead and I'm going to complete this problem with my chain rule, taking the derivative of the 3x and multiplying it on the end. So you guys, on this one, I would definitely multiply the 5 and the 3 and put those in front as 15 e to the 3x. And guys, remember, even though going from, so let's go back to the e to the 2x. Going from this step 1, the original function, down to our ending step, it looks a lot like power rule, doesn't it? It looks like we took this 2 and we just stuck it in the front. You guys, you can think about you can think about it like that. Look, that's what we did here too. We took the 3, we stuck it here with the 5, and it became a 15. It is going to work like that, but I don't want you to start confusing it with the power rule, because what's the difference? Yeah, that 3 does come down in front, but it also stays here. We don't take one away. So I really want you to be clear that you don't just start getting complacent and saying, oh, well, that number is just going to come down in front. This is basically power rule, because it's not. That 3 comes down because of chain rule, not power rule. You never, ever, ever get to change what's here. Okay, so let's do another one. I've got y equals 7 times e to the 3x squared plus 5x. So let's deal with this one step at a time. This 7 is a coefficient, so it comes straight down. This e to all of this nonsense is an exponential term, so it comes down exactly as is. Now, I've dealt with the exponential part of the problem, and now I got to deal with the chain part. This is definitely not just x. What is the derivative of 3x squared plus 5x? Well, that's going to be 6x plus 5. Notice, because that derivative has 2 terms, I've got it in parentheses. Now, technically, I'm done, right? I've taken all the derivative, used all the rules that I need to use. But you guys, on this one, what I would do is I would take this 7 and I would distribute it to both of these terms. So you could write this as 42x plus 35. And then you have your exponential term. Make sure, if you do that, which I would recommend doing that, it looks a lot nicer. Keep these in parentheses. It says that this e term is stuck to both of these terms with multiplication. So just being aware of parentheses is important, of course, and I know I say that all the time, but it is. So you guys, we had the e stuff, and then we had the natural log. So our second new rule we learned on Monday was how to take the derivative of a function of natural log. So it is logarithmic, and remember, this is the only logarithmic function we take derivatives of, which is nice for us, because it turns out really nice, guys. So when you take the derivative of the natural log of x, again, there's a lot of complicated mess that is involved from getting to here to here. But we did not have to worry about that. We get the end result of 1 over x. So you have the natural log of x, you take the derivative, it becomes 1 over x. So if I have, let's put some chain rule in there. If I have the natural log of 3x plus 5, well, it's not just an x, but because I have the natural log in there, that's my first rule to use. I have to use the natural log rule for derivatives first, and then I can deal with this part at the end with the chain rule. So guys, remember, you have the natural log of something, it becomes 1 over that thing. So in this case, I have the natural log of 3x plus 5. It will become 1 over 3x plus 5. So I did the natural log part of it, noticing just like with the exponential, this term comes down exactly as is. I haven't taken the derivative of it yet. But because it's not just an x, this is where the chain rule comes in. The derivative of 3x plus 5 is 3, so I'm going to stick that on the end. Remember when you have this fraction, remember that the 3 is a whole number. It's 3 over 1, so you can absolutely put it on the top. So the way I would write this problem is that your derivative equals 3 over 3x plus 5. And just a quick note of warning, you're going to have a lot of answers in your work that are fractions with something on top and something on the bottom. Even though there are 2 3s, there's a 3 on top and a 3 on bottom, remember that you cannot cancel these out, right? That is not how that works, because you have more than one thing down here connected with a plus or minus. You can't just divide a 3 out of the terms. Basically, you can't pick and choose what you divide something out of. So just be really careful. That's another kind of algebra review situation. Don't try to cancel stuff out that doesn't cancel. This is what it is. This is what your answer is going to look like. Let's put a coefficient with your natural log, because, you know, we can, and we haven't done it. Let's do y equals 8 times the natural log of 4x squared plus 5x. All right, so taking the derivative. Your first step, if you have a coefficient, is to go ahead and bring that along. And then your second step is to deal with the natural log part. I've got the natural log of this. What's that going to turn into? Well, it's going to turn into 1 over this. Exactly the same as it was in the original problem. This is times here. We'll deal with that in a minute. And then on the other side, I'm going to multiply by the derivative of this. I get my chain rule in there. So let's go ahead and put this in parentheses because it's going to be more than one term. It's going to be 8x plus 5. Okay, so from here, this coefficient is a whole number. It's 8 over 1. This term is also whole numbers. It's over 1. Both of these can go together on the top. So you can have the 8 and the 8x plus 5 up on top. And on the bottom, you have 4x squared plus 5x. And you can absolutely distribute this 8 to both of these terms. So let's do that. We'll get 64x plus 40 over 4x squared plus 5x. Okay, so let's see. You guys, there's no canceling to be done on this one either. So you can't like take these two terms and act like they're alone and do some reducing. Same with the 40 and the 5. You can't do it, you guys, so just leave it as is. Just erase stuff I didn't want to erase. Okay, So, again, that was just a little bit of review over what we did last time. And I will say, chain, power, these new exponential and log, those are going to be your most important rules as we continue. Yes, we have the product rule and the quotient rule. You're going to see as we go on that we don't use those as often, which I know is probably good news. They're not our favorite thing to do. But guys, power, chain, exponential, log, these are the really important ones that we're going to bring with us, you know, as we learn new stuff. So you really want to be clear. And sure, you know, have the product and quotient in your mind, make sure you know how to use them, but we don't use them half as much as these others. I'd probably say power and chain, I mean, can you think of a problem that we've done without the power rule? I mean, maybe your basic, we did this without the power rule. But yeah, guys, so it's all over the place. And the chain rule just keeps showing up even though we don't ask it to, right? Okay, so the second thing I want to do with you, so we did some review. Notice we got power review, we got chain, and we got the other two. In chapter 12, like I said, there's a lot of algebra involved in the steps you take to find your solutions. So yes, the differentiation, the taking the derivatives is going to be really important, but there's so many supplemental steps that involve algebra that I want to make sure we have a good foundation. And because I don't know the last time you took math, maybe it was last semester, maybe it's been 5 years, I don't know, right? So, and I don't want to assume that you just remember this stuff, so I'm not going to. We're going to review it. The biggest algebra thing we have to remember how to do is the factoring. When I factor, now I can factor anything. You know, there's a lot of different expressions that you can factor, and you do it in all different ways. For example, if you have 4x squared plus 16x, and I asked you to factor that, well, both of these terms have common factors. This would be the method where I use greatest common factor, right? What would I take out of these? I would take out a 4x. From both terms, what would I be left with? An x plus 4. So that's one factoring method, just taking common terms out when they all have something in common. So yeah, there'll be a little bit of that. That's not what we're going to review. We're going to review when it's harder. So for example, if I have x squared plus 4x plus 3. So if you have to factor this, well, here's the deal. You can't take something out of all three terms because they don't have anything in common, all three of them. So the greatest common factor method, like we did here, is out. So you guys, we use that quadratic factoring, and you've done it before. Some people like to call it reverse FOIL, but either way, we're going to go from this to this. It's going to be a term that has two binomials. So you take your trinomial, your 3-term problem, and you rewrite it as 2 binomials. So we're going to have 4 terms that we need to find. So this is the stuff we get stuck on because we just don't remember, and it's a real use it or lose it type thing. When you're using factoring all the time, it just makes perfect sense. And then if you haven't seen it in a while, you need a refresher, and that's totally fine. So you guys, these 4 terms, the 2 first terms are going to come from factors of our first term in this trinomial. So our first term is x squared. Factor that into 2 factors. You guys, it's going to be an x times x. So I got that down. Those are going to be your first 2 terms. So I'm halfway done. You guys, where do the 2 second terms in your binomials come from? They come from factors of your last term up here, of your constant, the one that doesn't have an x on it. So This one's pretty easy because if I try to take factors of 3, I only have one choice. It has to be 3 times 1. But you guys, you're going to notice in some other examples we do, sometimes I have more options on how to break this number up. So you guys, what I want to do, even though I know 3 and 1 are correct because I don't have another choice, the easy way to tell if you've got the correct numbers here are to add them up and see if they equal the number here in the middle. So I picked 3 times 1 because I had to again, but I just make sure 3 plus 1 equals 4, right? Yeah, so that means, yes, these are the right numbers. So I'm going to go ahead and I'm going to put them in my terms down here. Now, when it comes to plus or minus between these two, if your numbers here are both positive, which ours are, because I needed positive 3 times positive 1 to make this positive 3. If they're both positive, then there's both plus here. You'll know when they need to be negative. So you guys, that's the easy factoring. It gets a little bit harder. Let's look at this one. Let's do x squared. I made some of these up and I wrote them down. So let me reference. Let's do x squared minus 15x plus 36. Okay, so let's get started. I know what I want it to look like, two binomials. I know how to get the two first terms. It's factors of x squared, which I know are going to be x times x. You guys, you'll always break up your x's like this. It'll always be x and x. But you guys, 36 has a lot of different options for factors, right? I mean, 36 is a pretty factorable number. It's one of my favorites because of that. And ooh, that made me sound like a big old nerd. Okay. Anyway, let's think of some of them. You guys, 6 times 6 is 36. I could use that, but you guys remember what my goal is. I'm looking in this case for a negative 15. 6 plus 6 is 12. If I subtracted them, 6 minus 6 is 0. You guys, there's no way to combine 6 and 6 with add or subtract that's going to get me a 15. So not 6 times 6. What about 9 and 4? 9 times 4 is 36. But you guys, is there any combination of 9 and 4 that you can think of that will make 15? Because I can't think of one. So not 9 and 4. Another choice. Ooh, 18 and 2. That makes 36. We're closer, right? I could figure out a way to make 16 out of that, but not 15. You guys, 18 and 2 aren't going to combine to make 15. So, what about 12 and 3? 12 times 3 is 36. And 12 plus 3 is 15, right? So I think I've got a winner here. So let's write 12 and 3. Here's the problem. 12 plus 3 is definitely 15, but what I'm looking for is a negative 15. How do I accomplish this? Well, if I had negative 12 plus negative 3, that would make negative 15, right? And just confirm your signage, negative 12 times negative 3 does equal positive 36. So you guys notice because they're both negative, it's going to be x minus 12 and x minus 3. So our signs matter too. If you're ever worried about one of these answers being right, how can you check these easily? Like on this first one, this is what we got. You could FOIL this back out and make sure you get back to where you All right, guys. So my power just blinked at my house for no apparent reason on this beautiful sunny day. So it kicked my Wi-Fi off for a second. So I lost you. Or I guess really you lost me because you're probably all still here. So sorry about that. Let me get that screen back up and you guys are going to have to tell me the last thing that you guys got because I'm pretty sure I was talking to no one for a few minutes. Just working my math problems for my own benefit. So you guys, did we get through this problem right here?
Yeah, you were telling us that we could just factor them and get back to where we started.
Okay, perfect. Okay, so luckily I didn't talk to myself for too long. Okay, so we got through that. And then, so I want us to do this problem here. So this one's a little harder because we have a coefficient on x squared. Ooh, I wonder if I'm still, you know what? I'm not going to worry. We're almost done. I'm not going to start recording again. I'm not going to worry about that. Okay. All right, when you have a coefficient on the x squared, it gets harder because not only do we have to consider the factors of that number. What is happening? Are you guys gone again? Oh, no, you're not. Okay. I don't even know, guys. I don't know what's happening here. Okay, but we're good. We're good. Okay. So we have to consider the order of our terms matters a lot more when you have a coefficient on x squared. So let's do this and get our setup. Now, it's not just going to be x times x this time. I have to factor the 4 also. So now actually there's a lot of different ways that you might do this. A lot of people use factor by grouping. When they have a coefficient on x squared, they think it makes it easier for them. I don't like grouping. I think it's just extra work. Some people use slide and divide, which if you know what that is, it works sometimes and sometimes it makes things more complicated and I do not teach it. But basically, whatever gets you to the answer is absolutely fine with me. This is the way I like to do it. And it's fast for me. It makes sense. So this is the way I do it. And if you like that, then, you know, you can do it that way. But if it's not broke, don't fix it, right? If you have a better way, or not a better way, but if you like a different way, then you do that. Okay, so we have two choices with 4, right? We could do 2 and 2, or we could do 4 and 1. I'm going to try 2 and 2 for example's sake. Now with the 5, that's just 5 and 1. There's no way around it. But let's try the 2 and 2. You guys, when I think about taking these two factors and adding them together to make the middle, I have to consider what's over here now too. So the easiest way to do it is to check your cross products. So when I say cross products, look how I have these written in 2 rows. Can somebody put Gracie outside? Okay, so cross product, you guys start up here with the 2x. Multiply it by 1. 2x times 1 is 2x. Take it down here, 2x, go up times 5 is 10x. So you guys, 10x plus 2x is 12x. So you guys, instead of just adding the 5 and 1, we take cross products and we add those together to see if we can get to here. Is 12x 9x? I don't think so. So that's not right. But remember I said that order matters. So before you start changing your actual numbers, try changing the, well, it's not going to matter with the 2 and 2. Never mind. Let's change our numbers. This has to be 5 and 1, so we can't touch that. But instead of the 2 and 2, let's try 1 and 4. That's another way to factor 4. Sorry. All right, so cross products. Let's do it again. Guys, shut it. Let's do it again, you guys. We have 1x times 1, and that's just x. 4x times 5 is 20x. You guys, 20x and 1x, is that making a 9? It's not. So there's a problem, but you think to yourself, hey, I already tried 2 and 2. What other choice do I have? Well, this is where, like I said, order matters. Instead of writing 1 and 4, what happens if I had written 4 and 1? You think, well, it's the same numbers, so is it really changing anything? Well, my cross products say yes, it is, because you guys, 4x times 1 is 4x, and 1x times 5 is 5x. Add those together, and I get what I'm looking for. All I had to do was switch the 4 and the 1. And you might wonder, why does that make a difference? Well, it makes a big difference in how we write our answers. So you guys, this is not only the correct numbers, they are in the correct order. As you write them down, so we use the cross product to check, or that's what I do at least. When you write down your answers, we write them down straight across. So we have these 2 rows of numbers. I check to see if they're correct with the cross product, but as I write them down straight across the rows, just like I did on the other problems. Here's why this matters so much, guys. If you FOIL this out, you will get back to where you started. If you had had those 1 and 4s in the wrong places, so if they were switched up, your answer would look like 1x plus 5 and then 4x plus 1. And if you FOILed this out, it would not equal what we started with. So again, order matters. We want to keep it straight. This is how I do it. And I know it seems like there's a lot of writing involved. I usually do most of that in my head. So this method is really fast for me because it's what I use. If you feel like it's really slow, but you like it, I would suggest, you know, keep using it and you'll get better at it and faster. If you have another method you like, that's fine. Just make sure you're getting the correct answers. Let's go ahead and stop there. I feel like that's enough review about the factoring and the derivatives for the day. And then you guys, on Friday, we are going to start chapter 12. And I know it's a Friday, but I want to get it started in an in-person class for those who get to come in person, which means, guys, if you're my in-person class, come to class on Friday so we can start a new material with me in person. And other than that, I'm going to let you go.